Today in Coordinate Proof World, we're going to be proving that parallelograms. So we're going to get 4 coordinates, and we're going to have to prove that something is a parallelogram. And there's 3 ways to do it. One way is you can prove that there are 2 pairs of sides that are parallel. And if you want to prove they're parallel, we'll use the slopes. That's the definition, maybe one of the easy ones. You could also prove that 2 pairs of sides are congruent to one another. That would involve using the distance formula. Basically a little bit longer than this one. So like this one's a pretty good one to use. And actually one of the easiest ones to use is this third one here. So like number 1 I like, number 3 I like, number 2 works, it's just a little slow. Number 3 says the diagonals bisect each other. So remember, that's when the diagonals split each other in half. And in order to do that, you just find the midpoint of each diagonal. And if the midpoint of each diagonal is the same coordinate, then we've proven that the diagonals bisect each other. So in this example, we have to prove that Lmno is a parallelogram. And I'll start by doing the slope method. I'll show you that one first, and then I'll show you the midpoint method. The distance you can do on your own. It's the same general idea. So first off, the slope of Lm is very easy because it's a horizontal line. So it's 0. Likewise, the slope of On is also 0 because it's a horizontal line. Now, let's look at the other ones here. What about the slope of OL? A little bit more tricky because we actually have to do work. So, OL goes up 1, 2, 3, 4, 5, and it goes over 1, 2. So the slope of OL is 5 over 2. Now to get the slope of NM, we'll do the same thing. Let's see, it goes up, gee, guess what? 5. And it goes over 2. So the slope of NM is also 5 over 2. Now we just need to write that concluding sentence. So for this I wrote, since the slopes of Lm and On are equal, 0, and the slopes of OL and NM are equal, 5 over 2, the 2 pairs of sides are parallel, meaning this is parallel to this, and this is parallel to this. This makes Lmno a parallelogram. You need this little conclusion part here. I know. Alright, so that's one way to do it with the slopes. I'm going to erase all this, and then I'm going to do it with the midpoints in a second. So, cool, let's do it. Okay, so with this method, what we're going to do is we're going to find the midpoint of each diagonal. And they should intersect at the same point. So like the midpoint of Ln and the midpoint of Mo. As long as they're the same coordinate, it means that these diagonals bisect each other. Like this red one is split in half, and this blue one is also split in half. So let's do a little work. So for the midpoint of Ln, what we're going to want to do, we're going to want to average the x coordinates, and we're going to want to average the y coordinates. So let's do it here. The x coordinates, we get -2 from L plus 2 from N divided by 2. The y coordinates are 3 plus -2 divided by 2. -2 plus 2 is 0, and 0 divided by 2 is 0, of course. And then 3 plus -2 is 1, divided by 2 is 1/2. Great. Now let's do the same thing for MO. So the same exact process, we average the x coordinates. We have 4 plus -4 divided by 2. Oh, look, that's 0. That's a good sign. And then we have, once again, 3 plus -2 divided by 2 is 1 over 2. And that is the same exact midpoint, exactly what we were looking for. So now we just write our concluding sentence. And this says, since the midpoints of Ln and Mo are the same point, the diagonals bisect each other, making Lmno a parallelogram. So that's 2 different ways to do it. You can choose whatever way is your favorite. You also could have used the distance formula, but it's a little slower.